Today, we will be concentrating on one of the methods of pitch detection, autocorrelation. Basically, autocorrelation is the comparison of a segment of a song, recording, or piece with another segment of the same recording. The output you receive from such a comparison takes us one step closer to less pondering and more playing. Once we have selected a segment, let's consider its window size to be W. We are going to compare xj, that is, one part of the window, to a slightly delayed xj plus t. Let's call this delay tau. As you can see, we have tau c, which is an effective center that moves with tau. As the comparison takes place, we get an autocorrelation like so. Let's see how we got there. Diagram 1 and Diagram 2 shows autocorrelation output of the red portion of the signal. Let's break down the process. The segment selected in red is compared with itself. As we move the lower segment, the peaks start lining up. The more the peaks line up, the higher the peak we get in its autocorrelation. It is at its maximum when all the peaks line up. From this, we can obtain the pitch period or the fundamental frequency. This is the basic foundation of how autocorrelation works. However, we would like to enhance its features. How can we detect pitch more precisely but keep the computing speed at a maximum? The following equation was devised by Philip McLeod at the University of Otago, New Zealand. Our goal is to provide normalization. Here's the autocorrelation equation. Now here's the square difference function. We take the autocorrelation function out of the SDF equation and in the process get m dash. Keep this in mind. Here's an equation Philip McLeod devised to find specialized normalization of autocorrelation. The numerator is the autocorrelation function and the denominator is m dash. Moving ahead, we replace the autocorrelation function with the square difference function. With this equation, we have successfully combined the properties of autocorrelation and the square difference function to obtain our goal, which is, from autocorrelation, zero center reference, which is helpful in knowing which maxima are important. From square difference function, we obtain peak stability since SDF has stable minima. And lastly, normalization of autocorrelation has greatly improved. Thank you.